Hi, pre-calculus students. Welcome again to my living room. And this is section 1.2a. There will be a 1.2b. There's a lot in these sections, and so I split this one up. Again, these things you have seen before, but it doesn't mean that you don't need assistance and you don't need to see it again. Let's see, what did I want to, is my cat around? I was going to introduce you to Princess. I don't see her. That will be for another video. So pre-calc 1.2a, characteristics of functions in their graphs. Notice I put a note up here, GC, that's graphing calculator or no graphing calculator. So this is important, okay? I know in Algebra 2b and really every algebra class in geometry, you used a calculator a lot. That is not true in pre-calculus or higher level math. You would think that in general, the higher level the math, that the more you would use a calculator. That is not true. Okay, so it turns out that in calculus, when you take your AP exam, it is half calculator, half non. We actually rarely use a calculator in calculus. So how do you know when in your pre-calc book to use a calculator or not? If you take a look, you'll see in section 1.2 that you would probably never notice it before until, let's take a look at problem number, let's see. I'm trying to find where there's a graphing. Oh, on number 85. On number 85, there is a graphing calculator symbol here next to number 85. That and on number 86. So on number 86, right next to it, graphing calculator symbol. Okay. On all the other problems, or most of them, just most of them, there is not that symbol next to that section or next to that problem. That means you are to not use a graphing calculator. Sometimes I don't agree. Sometimes I think you need one, and they didn't say that you could. Okay, so, but in general, follow those rules as to whether you can use a calculator or not. So here we go. Number one, solution points are important points of a function in a graph. So how is y equals x squared related to this picture? So I am sure you already know that if I asked you to draw y equals x squared, this is the picture you would give me, this parabola here, vertex at 0, 0. Notice the point 1, 1 is on the graph and the point -2, 4. These are called solution points, okay? So the way a graph, how come y equals x squared makes this picture? Because it is a picture, this graph is a picture of the points that make this equation true. So solution points make equation true and lie on the graph. That is how they are related to each other symbolically and graphically. Notice the point 0, 0, x is 0, y is 0, makes the equation true. Notice the point 1, 1 makes the equation true. Notice -2, 4 does. Notice that this point right here, 0, 3, is not on the parabola and does not make the equation true. 0 squared is not equal to 3. So when you are asked on number 10 in your book, which of these points, or both of them or none of them, are solution points to this equation, right? What they mean is, does it make the equation true? So let's check it. Let's put in a 1 for x, right? And a 5 for y, right? That would be, need something to erase with, right? That would be 5 equals 4 minus 1 minus 2. Let's check this out. 1 minus 2 is a -1. The absolute value of -1 is 1. 4 minus 1 is 3. 3 is not equal to 5. 1, 5 is not a solution point of this graph, this equation, and it does not lie on the graph if you were to draw it. Let's try 6, 0. Okay, for 6, 0, when we put a 6 in, and for x and a 0 for y, we get 0 equals 4 minus 6 minus 2. Notice the absolute value of 6 minus 2 is 4. 4 minus 4 is 0. And we get 0 equals 0. This is true. 6, 0 is a solution point to that equation. And if we drew that graph, it would lie on the graph. Now, what is an x-intercept? The x-intercepts on this graph are in blue. And the y-intercepts are in purple here, if you can see the difference there. So an x-intercept is a point that intercepts the x-axis. So notice that this is the point 1, 0, 2, 0, and negative 2, 0, right? So what happens then with an x-intercept, it is some x value and 0. Notice the y is always 0, meaning it doesn't move up or down on the y-axis, meaning it lays on the x-axis. What is a y-intercept? They intercept the y-axis. Here is the point 0, 1. Here is the point 0, negative 1, and 0, negative 2. There we go. Notice then that always for a y-intercept that the x is 0, meaning it doesn't move the point left or right, and there's some y value telling you where you are on the y-axis. Okay, so let's try number 26 from your book. They are looking for the x and y intercepts of y equals the square root of 2x minus 1. Okay, so to tell you the truth, what I always do the y-intercept first because it's so easy to put 0 in for x, right? So let's get the y-intercept. The way we get that is we're going to have y, and if we're looking for the y-intercept, we need the x to go. So it makes sense that we put in a 0 for x and we're looking for the y. So to find a y-intercept, we put a 0 in for x, and we get the square root of a negative 1. Notice this is imaginary. This graph that we have here, these are real x's and y's. The square root of a negative 1 is imaginary, meaning that there is no y-intercept on the real plane. If you put this equation into the calculator, it would almost look like it has a y-intercept. Another good reason why we do this by hand, because we know there isn't one. Okay, x-intercept, that is where we put in 0 for y, right? And right here, and we solve for x. So I hope I'm leaving you enough room. Let's put in 0 for y and solve for x. Okay, to solve for x, I'm going to square both sides to get rid of the square root. 0 squared is 0. The square root is gone. 0 equals 2x minus 1. And to get the x alone, then I am going to add 1 to both sides and divide by 2. And I get an x-intercept of 1/2 and no y-intercept. Notice when you put a 1/2 in to the original graph, 2 times 1/2 is 1. 1 minus 1 is 0. I, in fact, do get a y of 0 there. All right, equations of circles. I don't believe you have seen since geometry. So they ask a lot of different questions. So that's why we have quite a few problems that we're going over here to refresh your memory. Here is an equation of a circle. X minus h squared plus y minus k squared equals r squared. And here's a picture with the variables, right? So what a circle is, it has a center and it's all the points equidistant from that center, and we call that distance r. So we know that if a point lies on a graph it's called a solution point, and we call it XY. So X and Y are a point that lie on the graph. Notice the center is very important in a circle, but it does not lie on the graph of the circle. So we have to call it something other than XY. So we call it HK. So where does this formula come from? Well, it's the distance formula. Take a look. The length of the radius, or the dist, is the distance between these 2 points, right? So when you do the distance formula, right, you get x minus h squared plus y minus k squared equals r squared, okay? Almost, right? When you do the distance formula, which we will call the radius, you get the square root of this. And then when we square both sides, the square root eliminates and we have r squared. So we'll show that in class. It's kind of cool. So your center is HK, your radius is r, a solution point is on the circle, and we call it XY. So write the equation of the circle, of a circle given a center point of 4, -2, and a radius of 3. So here's my h and my k. All I'm going to do is fill in the equation of this circle. So I keep my x, right? We know most equations have x's and y's in their solution points. X minus my h goes here, plus y minus my k goes here, right? K is a -2. So that will end up being a +2 equals, and then my radius squared goes to the right of the equal sign. That would be 3 squared, which is 9. We could write that as a 9. Okay, what if you have been given the equation of a circle and you were asked for the center and the radius? Well, let's take a look. Let's compare. Okay, x, oh, we have a minus and a plus, and my h must be a value of 1/2, but it must be negative, right? Because this would be x minus a -1/2, right? So notice we had a plus sign there, but this is still a positive, right? Minus a negative. My h has to follow a minus sign. My h is a -1/2. Let's find our k for the y value of the center point. My k, let's see, I have to have y minus, and my k follows a minus sign. My k must be 10. Notice when I match here, r squared equals 16. That means that my radius must be 4. A little harder. What if they say, write the equation of a circle for a diameter with endpoints -4, 3, and 4, 3. Okay, so they just gave you 2 solution points, right? Because here's a diameter, right? This is a diameter here that goes all the way across the circle through the center. And this could be the point -4, 3 here. And this could be the point 4, 3. Okay, so what we need is, we need a radius, right, to put right here. And we also need the center point to put right here. Okay, well, let's take a look here. If this is a diameter, notice the center point is in the middle. It's the midpoint of the ends of the diameter. So to get this center, I left some room up here to do work. The center will be using the midpoint formula. Let's add up the 2 x's and divide by 2, and let's add up the 2 y's and divide by 2. And we get the center point is 0 and 3. So we'll put that right here, 0 and 3. Okay, so we just found this center point of 0 and 3. So there's a couple ways to go to get the radius. The radius is the distance between these 2 points here, right, or these 2. Or what you could do to get the radius is find the distance between the 2 points you have here and take half of it, that would be the radius, right? And then we would square it. Oh, boop, gotta say that. We'll square it to put in our formula. That was supposed to be an R squared right there. All right, so let's take a look here. Let's just use our diameter points, right? So let's find the length of the diameter, right? So 4 minus a negative 4 is 4 plus 4, right? So that's 64 plus, and then let's find the difference between the y's. 3 minus 3 is 0. Oh, okay, so 0. So using the distance formula for the diameter, we have here 8 squared is 64, and the square root of that is 8. So the diameter has a length of 8, and if I divide that by 2, I get the radius is a length of 4. I would have also found that if I had found the distance between the center and an endpoint. And so we'll put a 4 right here. The radius has a length of 4. And of course, in the formula, it's being squared. Okay, how would we, last one, probably had enough of these, right? Here, let me move this over a little bit. How would you write the equation of a circle if you had been given the center point and a solution point, an XY point? Okay, so let's take a look. First of all, the center point we can put right in, right? This is our H and our K. So let's put in the 3 right here, H. And of course, when we put in our K, that's minus a negative 2. So that's plus 2. So if I just had the radius, I would be all set, right? Okay, well, let's take a look. I just want to show you, we have a lot going on here, right? And so I'm just going to draw a picture of the number 74 that we are working on that's in the text. Okay. We are saying there's a center of 3, negative 2, and a solution point, meaning it's on the graph of negative 1, 1, right? Well, notice that the distance between those 2 points is the radius, and that's all that I'm missing here. So let's do the distance formula to get that radius, and we'll put it in and square it. So right here, I've got a little bit of room right here. So I will subtract the 2 x's. Negative 1 minus 3 is negative 4 squared, plus, I'll subtract the y's. 1 minus a negative 2 is 1 plus 2 is 3 squared. Let's see, this is 16 plus 9 is 25. When you take the square root, you get 5. So the radius is a length of 5. And when I square it, I get a 25. So notice drawing pictures helps you. Okay, more examples and hints. On 87B and C, that is stats you're putting into the calculator again. Remember, when you've been given years, you start with the earliest year as a 0 and any years after that. For instance, 5 years after your first year, you would input as a 5, not as that year. I've also, just like in section 1.1 and 1.2a, I still have those graphing calculator notes available to you to help you with the stats. Okay, let's see, those are on Schoology under that assignment. Okay, on B and C, they ask you to graphically answer some questions, and algebraically. You only need to do graphically, not algebraically by hand is what they're saying. Okay, one last question. On number 60, what if they ask you to use a calculator to find the x-intercepts of a graph, such as x squared plus x minus 2? Okay, I did include how to find x-intercepts on a graphing calculator in the helpful hints, but let's look at it together, right? So first of all, I turned off my stat plots because I want to graph y equals. So just so you know, if you were plotting statistics earlier, when you hit your stats, so when you go to second y equals stat plot, If any of your plots are on, you need to hit number 4 and turn them off. Otherwise, it's going to interfere with what you have on your y equals screen, which is what I have here. Okay. So the first thing I'm going to do to find the x-intercepts is just do a zoom 6. Just graph x squared plus x minus 2. Hey, if you already know how to find x-intercepts, you don't need me on this one. But what I'm going to do is instead of trying to trace to the 2 x-intercepts that I see, I'm going to hit second trace because it will go right there for me. So you hit second trace, which is calc, right? And we want the zeros, which is 2. And then it says, it starts asking you to go to the left and the right. Because there's 2 points, they want to know which one you want to go to. So the leftmost point, I'm going to cursor until I'm to the left of that point, and I'm going to hit enter. Let the calculator know that. And then it says, hey, right, can you go to the right? So I'm going to cursor to the right and hit enter. And then it says, do you want to make a guess? You don't need to because you are super close to that x-intercept. And you hit enter and it goes right there for you. That in fact was a -2. So the x-intercepts, I have one of -2. Then for my x-intercept to the right, again, second calc, and I'm going to choose 0. I'm going to make sure I'm on the left of that x-intercept. I'm going to cursor till I'm to the right of that x-intercept. I'm going to hit enter, and that is a 1. There we go. Thanks for hanging out with me again. Again, I know it was a little long, but it's our first time doing these things, so there's a lot of other little things we have to say. Have a great day.